Hello all, I hope you all are doing well. Today I'm here to give a small presentation about my subject for the ongoing spring semester. The subject is EEE-236 and the topic I have chosen is design and implementation of image processing techniques with system generator. By the way, I forgot to tell my name. My name is Yoginath Kanditi. So let's start the presentation. So these will be my contents. Um, First of all, I will be telling about what is image processing, and next I will give small brief introduction about what will be the image processing, and after that continuing with the abstract, and I will be telling the methodology what I will be proposing now, and also I will be telling about the existing methodology like what is the previous methodology, and also I will be telling the implementation how to do, and I will be showing the results of what I have done, and also I want to give brief explanation about the applications and future scope, conclusion, and then we'll see some references as well. So before getting into the what is image processing, I would like to tell about the VLSI. So VLSI, I think you all will be knowing, you are very pretty much sure about that. So VLSI is nothing but very large scale integration, which is the key for the digital integrated circuits. Also, VLSI circuits are used everywhere. Real applications which include microprocessor in a personal computer, laptop, and people use them at workstations. And also, whatever the graphic card we are using, the chips are inserted in that. So, and also digital camera or camcorder and chips in small cell phones and mobile phones, whatever we are using. So, VLSI is everywhere around the world. So one such very important application of this VLSI is image processing. So that is how the image processing has came into limelight. So basically the image processing which I wanted to tell you now is nothing but it involves performing operations, that's it. So if we take, performing our operations on an image. So why we need to perform operations on an image? To make it better, right? Or to get some important information from it. So it's like fixing or improving a picture, and it's like bit like working with the signals kind of in when coming to electronics background. And also first we will be giving the input as an image, and the output whatever we get is just to make a better image or some other important details we need to take from the given input image. So that's it. And see now on the screen you can see a picture which is not having good clarity. It is not of good quality, so it is some blurred. So if you want to get the exact image of the given input image, so then we get the exact image. So we cannot see the face properly, right? So if we use this system, then we can get the exact image. So let me get into deeper into the topic. So digital imaging is the main technique here we are using. So we digitalize the image. So whatever we are taking it is an input. And also the main purpose of digital image processing is to get information that our human brain cannot read, and for image enhancement. So the main thing is here the quality of the image is enhanced, and whatever the noise which it has considering is reduced. So better results can be obtained by modifying the image pixels. And why it is improved image processing that relies on hardware operations, right? So image processing is used to provide real-time image stabilization. So the main objectives are to change the contrast, brightness, and what they call the threshold of an image. The other common image processing techniques include edge detection and contrast stretching, blurring, etc. And all these things will be coming. So what we are going to do for this kind of things? So we just need a specialized and promising FPGA based platform to process all these informations. But what I wanted to do is I don't wanted to get into the advanced stage of this thing. So I just wanted to show you the basic level of what an image can be processed through. So in this system I will be using MATLAB and Simulink. So I will be designing a block in the Simulink using the Simulink blocks. From that I will be giving my image as an input. Then I will be converting it to the red channel inversion, and then after that I will be stretching its contrast, and I will be detecting its edge, and I will be getting the specified output for that. If you wanted to do it in a in an advanced level, then you need to use the FPGA based platform to process all the information for accurate results. Okay, so relative to traditional fast digital signal processors, reconfigurable boards like FPGAs makes this approach easier and more effective. Compared to programmable digital signal processors, FPGAs enable the implementation of continuous computations in which application-specific hardware with significantly better performance. So that is why we will be using FPGA boards for image processing. But now I don't wanted to go that much deeper. So that is why I just wanted to make it sure I complete it with the MATLAB or Simulink itself as of now. So coming into the abstract. So the use of image processing defines the existence of many technologies these days, like autonomous cars, image reconstruction and recognition, enhancements of the image for forensic purposes, etc. Image processing is the process of transforming an image into digital, as I said previously, and also to perform certain operations. Why we are performing certain operations is to get some information, like useful information from it. Okay, so the image processing system usually treats all the images as 2D signals. Uh, it will be applying only 2D signals when applying some certain predefined methods. Okay, so it is our choice to get, to use 2D or 3D based upon the output we needed. So image processing requires fixed sequences. So they are bounded to some fixed operations only, because each picture has different pixels and different clarity. Like some picture may be 4K and some picture may be of less clarity, like that. So we don't know what type of image we will be getting. So this is why the image processor performs the first sequence of operations on the image, basic on every image, like it will be performing pixel by pixel. So each pixel is based on the RGB bits that define its color. So we all know RGB stands for red, green and blue. That is the main important, these three are the main important lines of an image. So the pixels are dependent on these three things. Um, so you can see the diagram here. Pixel of an RGB image are performed from the corresponding pixel. So now if we want to develop this thing in an MATLAB or Simulink, so how we will be starting the process? So whatever the work I wanted to do, the proposed work, it is simply based on, it is simply run in MATLAB Simulink. So the proposed work performs operations on the RGB of each pixel of the image with system generator. System generator, it is used only for the FPGA, like I said, advanced version. So for now, as of now, it is not required in this project, like whatever we are using Simulink. We just need some Simulink box, which are need to be installed in Simulink. We can find them in the library browser. So I will be explaining you each and every step. As I said, for advanced level, you need to require a circuit that is implemented using the blocks from its library, like Simulink library, and also it should support a black box that allows RTL to be imported into Simulink and co-simulated with the other, model simulator or Z-Links, Vivado. You have some tools, right, to work on it. So next, coming into proposed methodology, like whatever I wanted to do. So this research emphasizes the MATLAB configured with system generator. I'm not using system generator right now, because if I use system generator, then I need to perform it in FPGA board. So I just wanted to do it in the basic level. So I will be using only MATLAB, but in order, we require huge external libraries and functions in MATLAB, but the version I am using is MATLAB 2023A version. by my college. So I'm able to get the whatever the blocks I needed for operations which I needed to perform. So coming into MATLAB is a tool developed by MathWorks. It is useful for various engineering applications. Initially it was used only for performing high-level mathematical computations, but later various toolboxes were developed for performing various operations as well as applications as well. So what this MATLAB actually does, I mean like what the Simulink, what can we do? If you are using system generator, then system generator is nothing but it is a DSP design tool from Xilinx that enables the use of MathWorks, which are controlled or based on Simulink design. This is purely for FPGA design, right? As I said. So, like previously, we use experience the model with the Xilinx FPGAs or RTL design methodologies. But these are not required when using system generator. So in order to not use Xilinx FPGAs and RTL, now we are using system generator. That's it. Because the complexity will get simplest form. That's it. Designs are captured in the DSP friendly Simulink modeling environment using a Simulink specific block set. Yeah, this is what I wanted to let you all know, sir. We will be having some block sets in this Simulink. So based on our project, based on our needs, we need to install those block sets. So for example, now we need for this image processing techniques, we require DSP toolbox. So this will be consisting of the Simulink block set, where we will be getting the desired inputs like desired blocks. So for image, if you take an image, so we wanted to change the contrast and all the things. So then we can take the image from file from the Simulink, and then we need to add a MATLAB function, and for that we need to write a code for MATLAB function. Like I wanted, if the image has this many pixels, then convert it into these many pixels. Like we can use the converter, image conversion, data type conversion. So we can use all these things, right? And implementation. So coming into implementation, so Simulink, as I said, which runs in MATLAB, is an interactive tool for modeling, simulating and analyzing dynamic systems. So here we can, after opening MATLAB, you can see the Simulink option there. So after going into Simulink, we will be having the Simulink browser where we can find the number of block sets there. So we can take whatever the blocks we want for the respective project we are doing, we are working on. So the MathWorks Simulink provides a model-based design environment for the development of executable specifications of dynamic systems. It is fully integrated with MATLAB engine, so we can have graphical block editor, event-driven simulator, models parallelism, and DSP block set, Simulink block set, where we will be having sync sources. We can do a number of things in Simulink. Okay. So these are the things I wanted to tell: graphical editor, event drive, DSP toolbox, communication purpose. We can use it's a bunch of thing we can use. So see this is here you can see the Simulink library browser. What are there? So system generator is there, and Xilinx state flow diagram we can do. We can create Simulink coder, 3D animation, HDL coder, DSP system toolbox, and HDL support. So here we can see the image processing technique designs, like block, whatever block we need, those can be there. So these are the results. Like see here you can see my block diagram whatever I have taken. So I have taken image from file, and after that I have taken MATLAB function, and I have added edge detection block, and in order to view the display, or in order to view the output, I have taken video viewer. So I have connected all these things, and I have given my input image. So after that I have run the process. So this is what I have got my output as the after giving input. So this is the contrast stretching, and if we can see, this is the red channel conversion. For red channel conversion we are doing nothing but just taking the giving the code for MATLAB function. So coming into applications and future purpose, so in this study we observed that the images with optimum brightness and better image quality were results. So these can be used for a number of purposes for medical and etc. So we can use this for beyond medicine. Image processing finds utility in video editing. Yeah, people can edit videos, and we can remote monitoring. Remote monitoring is also available, and color pattern recognition, and we can do a number of things while using this. So the in this paper, in this presentation, the basic idea how image processing can be done in a model-based approach is studied. We have demonstrated some of the image processing application, which is done under Simulink. Also, this can be implemented using Zlink system generator for the advanced level. So in this presentation, I have shown how image can be read and detect. So we can also do grayscale conversion. There are a number of things in this we can do. And these are my references which I have taken to study on the project. Thank you. Thank you so much.